Okay, in this video, I'm going to show you how to remove metallic edge bleeding from your renders, taking them from this to this. So I've been using the metallic roughness workflow for a long time, and one issue keeps appearing, the area where metallic and non-metallic surfaces blend. Renders handle pure metal and pure non-metal correctly, but the in-between values often create a gray border, an artifact that stops the material transition from looking the way it should. And it's not just about transitions. Even with pure metal and non-metal values and zero blending, artifact outlines can still appear, breaking the clean metal to non-metal separation. Many artists refer to this as edge bleeding, and that's the term I'll use here. Technically, it's a metalness edge artifact, not the same thing as UV padding bleed. But since most people use edge bleeding to describe it, we'll stick with that. In this video, I'm going to cover 5 methods I've used to deal with this issue. Unfortunately, there's no magic checkbox in any render engine, at least not one I know of, that fixes this automatically. So instead, we have to rely on workarounds. Each method has its pros and cons, and I'll go through them one by one. At the end, I'll explain which ones I recommend, depending on your workflow. For the demonstrations, I'll be using 3ds Max with Corona Renderer. Nothing here is renderer specific. All of these techniques can be applied in most offline render engines. This video assumes you're already familiar with masks, EXR files, and basic material adjustments. And just so it's clear, these methods don't work in real-time engines like Unreal or Unity. They're strictly for offline rendering. This is probably the simplest method, because all you do is increase your texture resolution and amp up the contrast on the metalness maps until the edge bleeding becomes so small it's barely noticeable. If we zoom in, we can see that it is still there, but much less noticeable compared to a lower res version. But that simplicity is also why it's the worst option. It eats up unnecessary memory, gives you huge texture maps, and merely hides the problem instead of actually solving it. This method removes artifacts in an image editor by overlaying multiple renders of the same scene setup. The metallic and non-metallic components of the texture are separated into 2 materials and blended using masks. First, create a metal-only render. Set the material to 100% metalness, while keeping everything else, such as roughness and normal maps, the same. Next, create the opposite, a non-metal version of the same render with the material set to 0% metalness. Finally, you need a mask render, a black and white image where white represents the metallic areas and black represents the non-metallic areas. Once you import these into your image editor of choice, put the non-metal image as your base layer. Then place the metallic version on top and apply the mask. And just like that, you get a clean result with no edge bleeding. But there's one issue you might already be thinking about, the background. Each version of these renders interacts with the scene lighting differently, which means the background won't match. To fix this, you'll need one more render, a normal, regular version of your material, the one that actually has the edge bleeding. You use this to extract and restore the correct background, but that also means you need a background mask, so yes, another render. This results in a bit more accurate reflections. If you want super accurate reflections, then you would need to blend the reflections from the all-metal render and the all-non-metal render. And honestly, while thinking about how to do this, even I couldn't come up with an efficient method. The final result looks great, but that was a lot of work just to remove edge bleeding. And it gets even more complicated if you plan to do heavy color correction or lighting adjustments in post. All the examples so far used PNGs. But if you want maximum control, you'd ideally use a high dynamic range format like EXR. Doing this entire workflow with EXRs makes everything much heavier. And don't forget, your render times are now multiplied by 3, since you're rendering all those extra images just to do the touch-up in the image editor. I have mixed feelings about this method. I actually enjoy post-production, but this workflow is extremely time-consuming, both in rendering and in compositing. If you have the patience, it gives excellent results, but it's not fast. In this method, we start by duplicating the 3D object. We then create a thicker version by pushing the faces outward along their normals. You don't want to push them too far, just enough to create a subtle offset. From here, the idea is similar to the previous method, but instead of compositing different images in a photo editor, we're doing it directly in 3D. The inner object gets the non-metallic material, the outer object gets the metallic material, but this time we plug the metalness map into the opacity channel of the outer mesh. That makes the metallic layer transparent wherever the material shouldn't be metal, letting the non-metal object underneath show through. This removes the edge bleeding at the material boundary, because the transition is now handled by geometry and opacity, rather than by adjacent pixels in a texture. The only real downside is that this doubles your poly count and requires separate materials for each object. But in practice, I haven't noticed any significant impact on render time, so for me, it's not a problem. In this method, we once again duplicate the object, assigning the non-metallic material to one and the metallic to the other. But this time, we don't push any faces manually. Instead, we let the metalness map drive the displacement during rendering. If you're not familiar with how displacement maps work, here's the accurate mental model. Displacement is evaluated around a mid-value, usually 50% gray. Pixels at that mid-value mean no displacement. Values brighter than the mid-value push the surface outward. Values darker than the mid-value push it inward. This behavior is exactly what we want, because our metalness map contains only black, white, and some soft transition values along the border. So with two objects, one with no displacement, and one using the metalness map for displacement, the displaced object will rise where the non-metal areas are and sink where the metal areas should be. This effectively hides the parts we don't want and keeps the clean transition between materials. All we need to do is adjust the displacement values, and we get a result that looks surprisingly realistic. Unlike the opacity method, you can't see underneath the areas that get raised. They actually look like they have real thickness. Some offline renderers use a layered material system that blends complete material shading models instead of blending individual texture values. When that's the case, you can avoid the metalness interpolation step entirely, which means the gray edge simply doesn't appear. If you're using Corona Renderer, this method works extremely well. You create two separate materials, one metallic and one non-metallic. Then you stack them in a layered material and use your metalness map as the blend mask. This means the render engine mixes entire materials, rather than interpolating metalness values pixel by pixel, so you get a perfectly clean transition with no artifacts. Other render engines also have layered materials, V-Ray, Arnold, Redshift, Octane, Cycles, and so on, but not all of them handle the blending the same way. Some still interpolate metalness before applying the mix, which means the artifact remains. So whether this method works depends entirely on how your renderer handles material layering internally. If your renderer supports true material level shading blending, this is one of the cleanest and least hacky solutions you can use. It gives you correct shading, no extra geometry, and no compositing steps. Now that we've gone through all the methods, let's talk about which one you should actually use. Texture resolution method. I would almost never use this one. The only situation where it makes sense is if you're forced to work at something like 16K resolution and you've got a machine with a lot of memory to spare. Otherwise, it's just not worth the cost. Post-production method. Use this if you want to avoid increasing the poly count in your 3D scene, and you don't mind spending a bit more time rendering and compositing. The final result can actually look really good, even with relatively small texture resolutions. Just keep in mind that if you want to work in EXR, everything becomes more delicate and takes longer, from rendering to handling the files in your editor. Opacity method. This one works very well when you're working with materials like metal with rust that eats into the surface. It gives the most believable result because the metallic layer transitions naturally into the non-metal areas, and the variation feels physically grounded. Displacement method. This is one of my favorites. This method gives the best results on painted metal, especially where the paint is chipped or scratched, and the metal underneath is exposed. Displacement adds real physical depth, which makes those damaged areas far more convincing. I don't recommend it for rusted metal though. The opacity method works better there. The only downside is slightly longer render times, since displacement adds extra geometry at render time, but in my opinion, the final result is absolutely worth it. Layered material method. This is the method I would recommend first, as long as your renderer supports proper layered materials. Most modern offline render engines do. The real question is how the blending is implemented internally. When the renderer blends entire shading models instead of interpolating metalness values, this method completely avoids the edge artifact while keeping physically correct shading, with no extra geometry and no post-processing. That said, the post-production method can still deliver the absolute best final image quality, because it gives you full control over how metallic and non-metallic renders are combined. The trade-off is time. More renders, more masks, and more work in compositing. With layered materials, the only thing you need to verify is that your renderer truly mixes complete materials rather than blending metalness or other parameters before shading. When implemented correctly, this is one of the cleanest, least hacky, and most production-friendly solutions available directly inside the renderer. These techniques have saved me a lot of time in my own projects, so I hope they do the same for you. If you think I missed something, or if you found another method that works well, feel free to let me know in the comments. Thanks for watching, and I'll see you in the next video.